All right, so good morning everyone, and let's continue our discussion. We will continue our discussion on SDFS commands, Hadoop commands, right? So we have discussed that for last 2 days, and we will continue our discussion and take it forward. Okay, so let's go back to the session. Let's go back to the MS Word, and we will take it from there. All right, so let me check out. The first thing what I'll do is I'll go back to my VM and I'll start my VM. I'll say, let me share my screen as well. Share. And the first thing is start your virtual machine. Just power on virtual machine. Let it run. And in the meanwhile, let's go back and we'll start with So the last in our last class we had completed till this point. We were supposed to start Hadoop fsdu command, right? So let's understand what exactly this command does. Now the du command displays the length of the file contained in a directory or the length of the file in case it is just a file. So I'll give an example. See, as we all know, like we can store the data in Hadoop, right, in SDFS. And once you store the data in SDFS, you can execute various commands to check the file content, to create the directory, to see what are the files and folders present in this and that directory, right? But sometimes it is also important to know what is the size of the file, right? What is the size of the file? For example, if I say Hadoop fs-ls, right? So it just gives you the information about the files and folders, right? So if you see, look into my screen, Hadoop fs-ls, suppose it gave me fruit and sports and one more file, Ubuntu 19 dot something, right? So if you see this, if you see the screen, now if you see, the first two are basically directory, right? The first two, content output is basically directory, because you can see here dd written, right? And since it is a directory, it's just showing you 00. Okay. Now, the third one is basically a file. Okay, the third one is basically a file, and it is showing you some big number here, right? And this big number is basically something which you will not be able to identify so quickly. What exactly is this number? It's not it. Now there is a command called du. Okay, so you'll say Hadoop fs-du, or you can say Hadoop fs-du with the path, right? Whatever is the file path or the folder path. Now when you do so, then what it does, it says user sd user fruits, this one. Okay, the size of this folder is 19. Okay, the size of this folder is 19. See, earlier it was not giving you the size of the folder, it was just saying you 0 because this is just a folder. But now it is saying the size of the folder is 19. Okay, now similarly, if you say sports, then it says the size of the folder is 24, right? Similarly, if you say /user sd user ubuntu desktop amd64.iso, the size of the folder is this, right? Now what are these numbers? So these numbers are basically the total size in terms of bytes. Okay, so these are basically the size in terms of bytes. For example, take this number, the big number, right? So the first column is the total size of a file in terms of bytes. So this number, if you say, okay, bytes divided by 1024 will make you kilobyte, into 24 will make you megabyte, into 1024 will give you gigabytes. So it is actually 2.29 GB. Okay, the meaning, so this is basically 2.29 GB, right? So whatever number you get, they are basically a byte numbers. It's not that they are basically a byte numbers. Okay, now the second number, see here, the second number also looks same, exactly same. Okay, and why it is same is because of the replication factor is equal to 1, right? In your company level, if you have access to the company's cluster, you do the same thing, and you will see them as a multiple of 3, right? So what I'm saying is, in the real-time cluster, you will not see 19 here. The second parameter would be 19 into 3. Okay, again here the second parameter would be 24 into 3. Again here the second parameter would be this big number into 3, right? Because it will be replicated 3 times, so you will see here into 3 factor. Okay, now what actually, see, what I had done was this Ubuntu 19, whatever you were installing, is not it. So what I did is I copied this Ubuntu 19 into my Ubuntu system. The image of this Ubuntu, I copied that into my Ubuntu system, and then I said Hadoop fs-put, and that is the reason I was able to show you this file. And why did I do that? So that I can show you something in GBs. Okay. Yeah, so let me go to this folder, Hadoop installation downloads. All right, so I'm here now. See what I did, I copied this file. Okay, I copied this file into my VMware like this. So sometimes the drag and drop might not work, so you just have to retry again. Okay, so take this, just a minute. Yeah, take this, and see here it is saying not allowed. It is saying just not allowed, right? So sometimes this might not work, and if it is not working, just restart and then it should be all good. The other way would be, I'll say Control C and try to say paste, right? So if that drag and drop is not working, this is what you can do to copy the data from your Windows to Ubuntu. Okay, Control C, Control V should also work. So what I did, I copied this Ubuntu ISO file here in my desktop, and then I opened my Hadoop, and then I said Hadoop fs-put this file into SDFS. Okay, and why did I do that? I did that just to show you the gigabytes of data in SDFS. That's not it. And that was the only reason I did this thing. Okay. All right. So let's move on, and we will see that also. All right. Now you can also say Hadoop fs-du and your file name, right? The complete path of the file name, and only the file name if that exists in the default directory. So it will give you this number. Is not it. And now what you can do, you can also say Hadoop fs-set replication factor to 3. Okay, set replication factor to 3, and Ubuntu 1910 desktop AW and so on. So when you do that, what happens is it sets the replication factor to 3, right? It sets the replication factor to 3, but as I've told you, it will not copy it right away, right? Because we are working with only single node, right? But then if you say Hadoop fs-du, the same Ubuntu, then it will show you the first number is, the actual size of the file. The second number is what would be the size of the file, what would be the size taken by the file if the replication is successful, right? So it will be always into 3. See, 4 into 3 equal to 12, right? So this proves that the second parameter is basically your total number of size when the replications are all met, right? So okay, now maybe like this byte number looks so tricky, whether it is a gigabytes or whether it's a megabytes and so on, right? Now you may be interested to see these numbers but in form of human readable format, right? So if you want to see this number in form of human readable format, then there is something what you can do is you can say Hadoop fs-du -h, and H stands for human readable format. Okay, and then you give the file name, and then it says 2.3 gigabytes is basically what it is going to consume, what it is basically the file size. Okay, and 6.9 gigabytes is basically what it is going to consume if the replication factors are all met and set. Okay, so let's go back here, and it is still copying. I just wanted to show you this. Okay, let it come and we will see that practically. Okay, all right. Now display some free space in SDFS. Sometime you may be interested to see how much space is occupied and how much space is free, right? So you can just say Hadoop fs-df-h, right? And then you give a path, that is a root. I'm saying given the status of root path directly, not /user sduser, but a root path directly, right? So this gives you the output like this. sdfs localhost 9000. This is basically your IP address, right? And the port at which your SDFS is accessible. Okay, and it's saying the total size is 78.2, the use is 2.3, the available is 53.0, and the usage is only 3%. That means you have only used 3% of your disk space. Okay, similarly, instead of just giving slash, you can give me the information about my SDFS slash user SD user, and it says it will still give you the same thing, because at the end of the day, yeah, because at the end of the day your SDFS, like is same, right? No matter what it is. So it is still saying you dfs hyphen df hyphen h, and you are giving slash user SD user, then it says total is this is the IP address and port, and the total size is 78.2, used is this, and available is this, and the total use percentage is this, right? Because in this case you are the only user, and that's the reason it will give you the same details over here, right? In the real time you will see the different output, because there are so many people using it, but for us it is just SD user, right? And we are doing all the operations using SD user only. Okay. Now in the real time you can say something like this: tell me what is the, like, file space taken, and what the status of it on my dev system and in my production system, right? And this would give you the different output, because the configuration would be different, the amount of data you have, added there would be different, and everything would be different. Okay, let's move on. Still copying. Okay, all right, so I'll show you that, no worries. Now let's talk about removing the files and empty directories, right? Removing the files and empty directories. So you can always say hadoop fs -rm, and then choose the file name which you want to delete, right? Choose the file name which you want to delete. So I can say hadoop fs -rm slash user sd user slash some file, right? And it will go and delete that file. And when it deletes this file, it will put this file in the trash, right? Remember, we have enabled our trash by doing some configuration earlier, right? So it will take this file and put it into the trash. Now if you want to delete directory and subdirectory and everything, then you should use the command rm-r. Okay, you can say hadoop fs -rm-r slash user sd user dir, a directory name. So what it does, it basically deletes that directory, subdirectory, and all the files and folders present inside that subdirectories. Yeah, so as I have told you guys earlier, that in place of Hadoop FS, you can always use SDFS, DFS, right? So both the command would work interchangeably. Now you can say -rm-r, or you can also write it like this, but that is deprecated. Okay, but I'll just put that so that you can still use them. Okay, so you can still say RMR, but it is deprecated, right? It is deprecated, but you can still use it. All right, and let me not write SDFS, DFS, because you already know wherever there is Hadoop FS, you can always replace them by SDFS, DFS. Okay, so it has been copied here successfully. So let's open the terminal and go to desktop. Okay, so go to desktop, just say ls, okay, and just do a put on this file, right? So you'll say hadoop fs -put ubuntu, okay, just hit tab and just say dot, right? Hadoop fs -put this in my current working directory. Okay, now it will take some time because it is a 2 GB of data, right? So it is a 2 GB of file. It will take some time, but eventually it will copy the data into your SDFS, right? And once we have a gigabytes of file, you can go and execute your Hadoop fs -du -h commands and all, right? So that's how it is. Okay, let it take its time to copy those data. All right, let's move on. Now there is a command called hadoop fs -tail. Okay, this can be used to print sum of the lines of your file. For example, suppose I have 1000 lines of data, right, in a file, and I just want to, see the last 1 kilobyte of data from there. Okay, so you can say, see, this tail command is same as the tail command what you see in Linux. Okay, there is a command called head, tail, and so on. This also does the same thing. This also does the same thing. So what it does is it allows you to print the last 1 KB of data. Okay, so see here, sdfs dfs, which is same as Hadoop fs. Okay, hyphen tail slash user sd user opt log2.txt. So if I assume this is my log file, if I assume this contains my log file, then it will give you the last few lines from the entire log file. Okay, all right, so let's check this out. I think, okay, it says, all right, so my mistake, I should say start all.sh. You should start the service is not running and it failed. Okay, so once it started, you just can press up arrow to see the previous command, okay, and hit enter. Then it should take care of copying this data into sdfs. What it is saying, name node is in safe mode. Okay, so I'll talk about this safe mode also in some time, not today, but yes, sometime you may not be able to like copy the data, and it may give you a warning saying that the name node is in safe mode. Okay, so there is a way to get rid of this safe mode, but what I'll do is I will not copy it right now. Let me wait for some time. Okay, let me wait for some time and let's see what happens after some time. Anyways, we'll take our discussions from here. Okay, so we talked about this tail, right? So when you do tail, what it does not give you the whole content of the file. Okay, when you say cat, it starts giving you all the content of the file, right? And it may take a lot of time to give you the whole output, because it is going to print all the data of a file, right? But when you say tail, that means, hey, I just want to see the last few records. That's okay. All right, now let's move on. Hadoop fs test. This can be used for various operations, and let us understand that by an example. Okay, so see this. If I say Hadoop fs hyphen test or sdfs dfs hyphen test, and if I say minus hyphen e, and if I give a file name _2.txt, okay, then what happens, it will either return you 0 or 1. Okay, so when you say Hadoop fs hyphen test or sdfs dfs hyphen test, then it will either return you 0 or it will return you 1. Okay, now it returns that and it stores that in a variable which you can get access by using $? So let me show you this example. Let me say Hadoop fs hyphen test. Okay, Hadoop fs hyphen test hyphen e, and then some path name slash user sd user word2.txt, right? So I can just say word2.txt. All right, so see here, you don't see any output. Now if you want to see the output, what you need to do, as I told you, this command will execute. Okay, and this command output would be stored in a variable called $. Okay, let's say in a variable called $. And how do you get it is, you can say echo $? Right? So when you do that, then it means, hey, give me the output of the previous command. Okay, give me the output of the previous command. The previous command got executed and it might have written me some value. I want to see that value. I want to access that value. Okay, that is what you are doing in this echo. Okay, now I want to do one thing here. I'll say Hadoop fs hyphen ls. Okay, and let me say enter. All right, so see here. Now what I can see is, in my present working directory, I don't have word2.txt. Okay, but what I have is I have fruits and sports.txt. So let me do this again. I would do this again, and here I'll say fruits underscore sports.txt. right? So I'm saying Hadoop fs test -e fruits sports.txt, and this file actually exists in the mentioned directory. This file really exists. So now let's see the output of this. Okay, see, the output of this is 0. The output of this is 0, and the output of the previous example was 1, where the file did not exist. Okay, so what I can conclude from this experiment is 0 means exist and 1 means does not exist, right? So this is what I can understand from this discussion. You see here, fruits underscore sports.txt, they exist, and hence the output is 0, which means hey, the file exists. Okay, and 1 means does not exist. Okay, now that is what this e will do. Now let me go back to this e. Now see what is the meaning of e. If the path exists, then it returns you 0, right? So it checks if this path exists or not, whether it is a valid path or not, right? So in our case this was a valid path. This was a valid path, but this was not a valid path because word2.txt does not exist. All right, now let's go back and say we have done this too. The first two is done. Okay, now the next thing what I'll do is I'll say dfs sdfs dfs test -z, and I have given the same path, and see this path actually does not exist, right? So I've given the same path, and I said echo dollar question mark. Okay, echo dollar question mark, and what it gave me? It gave me 1 here. Okay, so let's see what exactly it is, right? So I'll copy this, and remember word2.txt does not exist for us as well. Okay, paste. So I'm saying sdfs dfs test -z. Z is what we are learning now. What is z? We will see. Okay, now let's run this. Okay, and again we will say dollar echo. It has given me 1. All right, now I'll do the same using fruits and sports. All that I need to do is I need to change this to z, right? Okay, and let me say $1. So it has given me 1. Okay, and let me do that for what to. Okay, so it has also given me 1. Okay, let's see what exactly this one means. Yeah, so now we are exploring z. Okay, so what it says, if the file is 0 length, then I will return 0. If the file is 0 length, if the file is of 0 length, then I'll return 0, otherwise I will return 1. Okay, so now what it has done is it has gone to this place /user sduser word2.txt. Do we have that file? Let me check. Hadoop fs -ls. Okay, so the file does not exist. Okay, now do we have the other file sports.txt? Yes, we have sports.txt. So what it is doing is it is just giving you 1 here, and it will give you 0. See what it says, it gives you 0. It gives you 0 if the file is of 0 length, right? Otherwise it will give you 1. Okay, so let me also add that point here. Still gives you 1 if even if file does not exist. Okay, even it will still give you 1 if the file does not exist. If the file exists and if the file is empty, then it will give you 0. Okay, let's move on. We have seen -z. Okay, now we will see -d. What does -d means? So -d means if the path is a directory or if the path is not a directory. If the path is directory, then it will return you 0. Okay, so -d, right? So let me do this. So see, this path is not a directory, it is basically a file. Okay, so since it is a file, it is returning you 1. But if this path would have been a directory, then it would have written you 0, right? So that's what it is. Okay. Now similarly you can also do other thing like -f to see if the file if the path is a file or not, -s if the path is not empty, or if the path is not empty then it returns you 0. Okay. -w if the path exists and write permission is there for your user, -r if the path exists and read permission is there for your user, and so on, right? So likewise you can just change the parameter of Hadoop FS test to all these various options, and then you can get access to the value by saying echo dollar question mark. Okay, now let's go back. Okay, and I'll say Hadoop FS hyphen put Ubuntu dot. Okay, so I believe the copy operation started now. Okay, but if you remember, when I was trying to do it for the very first time, it said the name node is in safe mode, right? So we will talk about that later, but I just wanted to let you know about this, that if it says name node is in safe mode, right, that means something is busy, the name node is busy doing something. What is that? We will talk about that in our next session sometime. Okay, and I believe, and I can see that, I think the command was executed successfully. So let's say Hadoop fs hyphen ls, hit enter. Okay, now see how fast the 2 GB of data is copied into our SDFS, right? And once you have this data, you can go back and then execute all your command, whatever we have discussed earlier. Okay, so let me just show you one command that should be fine. Let me just go up. Let me just go up. Yeah, what I'll do is I'll keep the replication factor to 3. Okay, so say paste, set the replication factor to 3, and then I would say give me the information of this file, or let me just say -h, so that you can see this information in the readable format. Okay, so it says replication factor is set to 3, and right click and say paste. Right, so it is checking the content, it is checking the size of the file. So it says the size of the file is 2.3, but since in your cluster you have you are trying to replicate it by 3, then it is going to take 6.9 gigabytes of disk space. Okay, that's what this command does, and remaining things please go and explore it, as I have just explained you. Just go and execute and it should work as it is. Okay, now Hadoop FS text. Okay, so this can be used to see the content of the file. This can be used to see the content of the file. And as I have told you, this text is little powerful than cat, which means it also has the capability to read the sequence file. Okay, and what is the sequence file? We will learn it in detail later, but right now understand that it is a file format in Hadoop. Okay, it is one of the file format. Like you have a CSV file format, you have JSON file format, you have Excel file format and all. So similarly, your sequence is also file format, which we will discuss later, but yes, it has the capability to read the data from a sequence file also. Okay, now see this Hadoop fs hyphen text word1.txt. So what exactly it is going to do is, it is going to give you the output from word1.txt. So let's see that little practically. Okay, so what I'll do, see, observe this. I'll say cd slash user local Hadoop. This is a place where I have my Hadoop installed. Okay, ls cd logs ls. Okay, so where I am right now, I'm in my present working directory. I am in my directory. I'm inside my log folder of my Hadoop. Okay, now when I say ls, these are all the log file, whatever I have, ls-ltr. Okay, so this gives me the detailed information about my log file, right? So what are, see, and in this case, if you see, you can see that the size of the file is really good, right? Now what I can do is, this file name node ubuntu.log, right? This file, let me check how many lines are there in this. Okay, so I'll say wc-l, okay, word count -l of this file. copy this, say paste. Okay, so I'm saying, can you give me how many lines are present in this file wc-l, right? So it says this file has 5957 lines. Okay, now let me copy this file into my sdfs. So I'll say hadoop fs -put. Okay, and hadoop sd user name node ubuntu dot log where dot. Okay, so it has copied this data into our sdfs. Now if I say hadoop fs -ls, you should see that log file also in our sdfs. Say this line, right? So I have successfully uploaded one such log file in my sdfs. So let's assume this is one kind of file. Now if you do a cat, let's see what happens. Okay, hadoop fs -cat. This is a big file, 5000 lines at least, right? So copy, paste. Right? So it has printed everything. It has printed everything. See this. It has printed everything for us. These are all the output. These are all the output. And it has printed so much that you are not able to even read them in the single frame. Okay? So that is what your cat will do. Right? Similarly, text will also do the same thing. Right? It will also read everything for you. Now let me go back and also show you this one. This one, tail. What does it do, right? So let's see this. So I'll say hadoop fs -tail. Okay, now see, it has not given you all the output, right? It has just given you few output from the entire file. Is not it? That is what the tail can do, right? So similarly, let's go back here, and when you say text, then what it does, it basically gives you all the output. It basically gives you all the output, and then you can say, I want to read the first three lines from a big file. So in Linux, okay, not in Hadoop. See, in Linux, if you say head 3, just a minute, head -3, yeah. So if you say head -3, okay, it gives you the first three lines. Now let me go back and say tail -3. It will give you only the last three lines. Okay, it gives you only last three lines. So if you see this example, in this example, this pipe is basically a redirection operation. Okay, which means I want to see, if you look into this particular command, let me explain you on the board. Okay, so what we are trying to learn is, I'm saying, like, what I've done is I have done hadoop fs -text, right? And what we did is we took that log file. And when you do this, what happens is you get the content, the whole content of this file on your screen. You get whole content of the file in the screen as an output, right? But you can always say pipe, okay? And this pipe symbol is not from Hadoop. This is basically a concept in your Linux itself. And when you do this pipe, then what happens? All this output, the output of this content will go to the next level. Okay, we'll go to the next line, and I mean we'll go to the next command, right? So when it goes to the next command, then you can say, hey, that output I want to say tail -10, which means give me the last 10 lines of this output. Similarly, you can say head -10. Now this head and tail, these are basically your Linux command. Okay, because see, once you are done with this execution, once you are done, once this piece of like statement is executed, it gives you back a data, right? It gives you back some data. Now that data, what you want to do, you can chain it out. Okay, you can say head, tail, or whatever you want to say. You can also say 𝗚𝗏 hyphen L, kind of, right? So this is called as a redirection in this example, right? So this is basically a separator between two commands, and what happens is the output of the first command will go as an input to the second command. Okay, and you can have multiple such pipe options. You can have multiple such pipes, so that one output will go to the next code for execution, and its output will go to the next, again its output will go to the next, and that's how it works. So this head and tail, what we are learning is basically from Linux itself. Okay, it's not from Hadoop, it's basically from Linux. All right, let's go back to the desktop again. All right, so let me show you one more example. So I can say, I'll try this. I'll say 𝗚𝗏 hyphen L. Okay, so see, it has given you the output, like the whole content has 5958 lines of data. Okay, let's move on. Now Hadoop FS Touch, what it can do for you is it can create a file, an empty file for you. Okay, see, touch is basically a command in Linux, but that same command works on Hadoop as well. Okay, so it can create a file of size 0. Okay, as well as it can update the timestamp of a file. So check this out: updates the access and modification time of a file specified by URI of the to the current time. If the file does not exist, then a 0 length file is created at URI with current timestamp as the timestamp of that URI. But let me put it in a simple way. Touch can be used when you want to create a file. Okay, so for example, I'll go to my desktop, to my home, and I'll say ls. Okay, and let's say I want to create a file called hadoop.txt. Okay, so I can see, if you want to create a file called hadoop.txt, there are many ways. Okay, one way would be, you can say cat hadoop1.txt. Okay, and not cat, sorry, you can say vim hadoop.txt. Okay, one editor will open and you will have to say escape:\wq, done. It has created a file called hadoop.txt. But I don't want to do that. I don't want to open that terminal and then say escape:\wq and all. So what you can do is you can say touch, okay, and say hadoop2.txt, right, ls-ltr. So see, it has also created a file for you, right? Which one is better? Of course the second one, because I don't have to go inside and then say escape:\wq. They all come automatically, right? So this can be used to create an empty file. Okay, done. This can be used to create an empty file, and it's done. Now the magic of this touch is, suppose, see, word1.txt. If you see this word1.txt, it says this file was created on December 10th at 1855. Okay, now suppose I want to change the created date of it. I want to change the created date of this, then I would say touch.txt. Okay, I said touch word1.txt, and let me again say let me say ls-ltr. Okay, now see, word1.txt timestamp has got changed. The created date has been changed to current time, right? This is what your touch will do in your sdfs also. Okay, so if the file does not exist, it creates the file, and if the file exists, then it updates the timestamp, right? And the command is same, hadoop fs-touch the file name. So if I want to create an empty file, I'll say hadoop fs-touch Hadoop fs-touch, and I'll say Hadoop 123.txt. So I'm expecting one empty file to be created in my current working directory. So if I say Hadoop fs-ls/user/sd user, then it should show me Hadoop 123.txt as well, right? It should show me Hadoop 123.txt as well. So it has created a file for us. Now similarly, let me take some example. Let's go back to this fruits and sports, which was created on 10th of December, right? So I want to, do something. I want to say touch on this file. So I would say Hadoop fs-touch and paste. Okay, enter. Okay, and let's say ls. So where is this file? This is the file which we wanted to touch, right? And if you see the output now, it says it is updated to the current time stamp. Okay, so let me see what the time in my Ubuntu. The time in my Ubuntu is Sunday 13th December PST. Okay, it is not with respect to IST right now. Okay, all right. So as per our system time, it is updated. That is what your touch will do. Okay. Now you may ask me, hey, can you tell me a real-time case where this touch would be useful? Okay. You will understand that later, but let me just give you a small idea where exactly this touch can be used. Yeah, back to the board. Now suppose what you want to do is you have a file, you have a path, say /user/hd user, okay, and say there is a file called data output. There's a folder called data output, right? So say this is a path where you have written some program which can update the data into this path, right? And here you have a lot of results. See, when you basically run a Spark job, or when you basically run a MapReduce job, then it goes and writes a lot of part files, part M0000 kind of thing, or maybe part R0000, or maybe part 0000 kind of file it creates. Okay, but when any job runs, it also creates a file called _success. Okay, which says that the job was successful. Okay, we will see that practically when we start exploring the MapReduce code. But what I'm trying to tell you here is, suppose there is a file. Suppose you want to replace this data. Suppose you want to replace this output with some file which is given to you by the client, saying that, hey, this folder should get these files, right? And then you want to trick your further MapReduce job or Spark job, saying that, hey, don't process this file because I already have completed this. How do you ensure that how do you ensure that your Hadoop does not like Spark does not rerun the program and like overwrite the data over here, right? So what you can do is you can just create a blank success file. Okay, you just create a blank success file, and your Spark job, and you can make your Spark job and MapReduce job understand that this is already a processed data, right? So what basically we do is, whenever we are given a path, we will check if the path contains a success file or not. If the path contains success file, then we will assume that this path is this job is already written by somebody, and we will not write any data here. We will skip that process, right? So what I'm trying to tell you is, you can trick by just creating an empty file called _success, and that is where you can immediately use touch command to make that happen, right? Otherwise, what you have to do, practically, literally, you have to create a success file where in your local, and you have to say Hadoop fs-put. Instead of that, you can just say touch, and then one success file will be created. Okay, let's go back. And we will. I'll answer all of your questions, guys. Let me just finish my discussion first. Okay, and let me go back to share screen. All right, so this can be done, right? Now similarly, there is a command called Hadoop fs 𝗙𝗏. Okay, and what does this 𝗙𝗏 do? It just creates a new file. Okay, it does not update the timestamp, but it just creates a new file for you. Okay, now similarly, you can have a Hadoop fs count, right? And what does this count do? This count can give you the total number of files and folders present in a directory. For example, you can say Hadoop fs -count -h for human readability and dot. When you say dot, that means current working directory. Always remember, dot means /user sd user for us. Is not it? Okay. Now when you do this, what it says, it is saying 1711 2.3 gigs. So let's see what exactly we get in our case, right? Say right click and say paste. All right, this time we have got 25, 32 and 2.3 gigs. So let's understand what are those, right? So the meaning of this line is there are 17 folders and there are 11 files and the total size is 2.3 gigabytes and the path is dot. Okay, similarly you can do it like this. Okay, so let's go back and say paste. All right, so it's saying there is one file, there is one folder, and the size of this is 19 bytes, right? So that's how it is. So it will basically give you the total number of files and folders. Fruits is basically a directory, right? So fruits is basically a directory. So one inside the fruit there is one file. So one file and one folder altogether. The size is 19, right? 19 bytes, and this is the path of the data. Okay, similarly you can do it like this. If you have a file, say demo.txt, do I have it? Let me check. Okay, it says no file and directory exists. So let me say Hadoop fs-ls and we would check the content of a file. So we have Hadoop 123.txt, or let me better take this. Okay, so Hadoop fruits sports.txt. Okay, so what it's saying is you are targeting a file, so there are 0 directories and there is only one file, which is what you have specified, and the size is 43 bytes. Okay, now similarly you can do something like find a file, right? So sometimes it is important, sometimes it is very difficult to locate a file. For example, you remember that the file name is this, but you don't know where exactly it is. Okay, so you can take the help of your Hadoop fs command to search for a file. So you'll say Hadoop fs-find. Okay, Hadoop fs-find, then you will say on this path, okay, find a file called fruit.txt. Okay, and hyphen name is, I want to specify the name of the file. Okay, so this will search fruit.txt in all the locations right from /. Okay, so let's go back and I'll say paste. All right, so in my case it says fruit.txt is located under /user sd user fruits.txt, right? Similarly I could have done like this. Let me say dot, right? So if I say dot, then it means I'm looking for current working directory. So it said, hey, the data is present inside fruits/fruits.txt. Similarly, I could have done it like this. Okay, now when I said /user sd user, it is saying, hey, that file is present inside this directory, right? So this can be used very, very handily when you have a file and you really don't, you just remember the file name, but you don't remember where exactly it is present. It will give you all the occurrence of the file, right? For example, you have written a MapReduce job or a Spark job, okay, wherein wherein the code says the data would be written in a file called abc.txt, for example, right? And you really want to find out where exactly they are present, so you will say abc.txt, right? Let me also try this out. Can I do something like this, right? So if you see, it also supports a wildcard character, wherein I can say, wherein I'm saying, hey, I want to search for a file whose name I really don't remember, but it is frui and blah 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 dot txt. Now you tell me, you search and give it to me where exactly they are. So it's saying, hey, I found something called fruits.txt here, and I found something called fruits_sports.txt here, right? So this also can be used. Okay, so let me just copy this and paste it in the notes. Right, so you can do this also. So it is possible to search them by wildcard as well. All right, now let's talk about the next command, disk copy, which is very very important and everybody uses it. Okay, everybody uses it. People will ask you in the interview as well, because as I said, everybody uses it. Okay, so disk copy is basically used when you want to copy the data from one cluster to another cluster. For example, I'll give an example so that you can understand it better. Let me erase this. Just a minute. Okay, so what we are trying to learn is, we are trying to learn disk copy. Okay, so let's assume you have multiple cluster in your company, right? So you'll have a production cluster, you'll have a staging cluster and all. And sometimes, let's say you have executed a job, okay, and that job is basically a production job, right? The job was executed by the team, and now what you want to do is, you want to bring that data to your staging cluster, right? So you want to say, hey, I have a data, this is my production cluster, prod cluster, right, wherein you have a lot of nodes, right, in which we have executed our MapReduce or Spark job, right? And then it usually go and writes the data back to your production cluster itself. The input is the production file system, and the output is the production file system, sdfs, right? Now once that is done, you have got some output here. Okay, and now what you want to do is, you want to bring this data to your staging cluster, so that you can do some analysis on this data. Okay, so that you can do some analysis on this staging data. For example, maybe writing another MapReduce job, or maybe writing a Hive queries and all. Now why exactly we are bringing this data to our staging cluster? Because we will be doing a lot of ad hoc query. Okay, and every ad hoc query will result in one or other Spark or MapReduce job. Every ad hoc query will result in one or other Spark or MapReduce job, right? And you really don't want to trigger your those job in your production cluster, because you are not authorized to do so. Okay, you're not allowed to run this without permission, or without intimating to the other team, because this production cluster will run all the production job, and you are not the only guy running your production job. There are so many people running the production job all together, right? So you just want to get the data once in your staging cluster, and once your data is back to the staging cluster, you do whatever you want, nobody cares, right? So you need something called disk copy to copy the data from one server to another server. Okay, now it is also possible that you have got the data, and you want to, uh, do some operations, and hence you brought the data to staging cluster. You did some operation, and then you have prepared a final output, right? And this final output should again go back to the production cluster, because one more job is going to get executed on this output. Okay, let's understand it more better. Okay, I'll explain it again so that you understand it more perfectly. Okay, now what I have is, I have a production cluster, prod cluster, okay, and I have one more cluster, staging cluster. Okay, see, in real time there will not be only one production cluster, there will be many, right? For example, where I work right now, we have almost 7 production clusters, right? And we have many staging clusters, maybe 10 to 12 staging clusters. Okay, anyways, so let's say you have let's say there was a job which you guys own, and that job got started in the production cluster, right? And now that job is going to execute a couple of steps: step 1, step 2, step 3, step 4, step 5. And what happened was, due to some problem, right, the job failed at step number 3. The job failed at step number 3, and it has taken almost 16 hours to complete step 1 and step 2. Okay, so don't assume that Spark job means it will be completed in minutes, right? Because in the real time there are long running job. It is completely based on the complexity of the job. Okay, so let's assume these two jobs were executed, and it took almost 16 hours, and it failed at this stage. Okay, so, and these are all these are all like not a parallel job, these are all sequential job. Output of 1 would be input to 2, output of 2 would be input to 3, and so on. Now, since it failed here for some reason, right? Now, what you decided is, you decided to bring this job here. You decided to bring this job here. When I say bring this job, that means the output of job 2, which was input to job 3. So you took the input of job 3, you copied it to your staging system. Now your staging system has got the input of job 3. Okay, and this is the code base which you own. That means you already have the code base in your staging, and you started running this job in your staging environment. Done? Okay. Now once it is done, it will write the output in your staging environment itself, right, under some sdfs path. Now what you want to do is, once it is done here successfully, because you are really not sure, you are trying to debug, and you really don't want to run it again and again in the production, right? And let's say you don't even have a permission to resume the job in the production, right? So what you did is, you brought the data, the read permission was given to you, you read the data into your staging, and you started running your job locally here, and then you got the output. You got some output over here. Okay, now this output, let's push it back to the production. Okay, this output, let's push it back to the production. So the output of this job 3 is pushed back to the production. So I can say this job is also now complete. Okay, now since this job is complete, now after some time, what you can do, you can ask your admin folks, DevOps folks, to resume the job. Okay, to resume the job, because you have done all the necessary thing, whatever you could, to run this job. Maybe there was some problem in your code, you fixed that in the staging environment, started the job because it was failing because of some null pointer exception, this exception, that exception, and all. And then you have fixed that, you ran that locally, it ran, and the output is what you have copied back to this cluster on an appropriate path, and then we will mark this as complete, right? And then when we go to the DevOps and say, hey, that job was failed, I have taken care of it, you just need to resume the job. You just restart the job from step number 3, and it should be all good. So it will resume the job from step number 3, but when it runs the job from step number 3, it identifies that, hey, the output file is already ready. The output file is already ready, and I have a success file already present there. So I will mark this as complete, and let me resume the job from next step. Right? and that is where your disk copy will be very, very handy. So it can be used to copy the data from one cluster to another cluster and so on, right? So that's what it is. So let's move on and let's see this. Okay, so we have understood the concept of, so right now we have understood the concept of a disk copy, right? So let's check this out. Okay, now let me go back. Okay, so see, this is basically a typical syntax of copying the data from one cluster to another cluster. Okay, so let's look into this syntax first. Okay, so you are saying Hadoop --config some configuration file. Okay, this will point to a configuration directory wherever all your configurations are stored, and you'll say disk copy, and you are specifying some configuration here, like my map memory would be 2 GB. Okay, and I'm saying let my mapper be 100 to run this -pb a copy, and this is basically your one production. This is basically your production sdfs cluster. So I'm saying from my production sdfs cluster, okay, under /tmp 𝗀𝗽𝗶𝗴𝗃 customer underscore tx, copy this to the staging system. So in this example, whatever you can see on white, they are optional. Okay? They are completely optional. So typically you can ignore this also. But what I'm trying to tell you is, user local Hadoop configuration will have a configuration file, and this file has all the information of establishing the connections. Okay. Now, when you do this properly, then you'll be able to copy the data from your local to staging, and production to staging, staging to production, and so on, right? So configuring this configuration file would be a headache of your DevOps team, right? Okay, and this, see, I'll tell you one thing, that disk copy will always trigger a MapReduce job, which means it is also a job. Okay, it is also a job which will take care of importing the data. So in our case, you are doing that, you are going to run that job in your staging cluster. You're going to say disk copy in staging. Okay, and you'll say disk copy the data from production to staging. Okay, so in that case, your MapReduce job will be triggered in your staging environment, right? And that's how it is. Now, how do we replicate that in our single node machine? Okay, so if you want to replicate that in a single node machine, then what you need to do is you need to go to map parent site.xml and make some entries. Okay, keep some entries like am.environment, map.environment, reduce.environment. Keep this environment, keep this setup ready on your map parent site.xml, and restart your Hadoop single node cluster. Okay, and then we can do a simple disk copy. So I'll show you that example here. Now what I will do is, we'll say Hadoop. Okay, now let's say Hadoop fs-ls first. All right, now see here, I have a file called fruit and sports.txt. Okay, I have a file called fruit and sports.txt, which I want to do a disk copy. So what is my command? Hadoop disk copy source and destination in this case, right? So the simple command would be Hadoop disk copy source. What is my source? My source is this. Okay, and what is my destination? My destination is /tmp /𝗀𝗽𝗃, or I don't know if that is there or not. So /tmp fruits underscore sports 1.txt. Okay, so this is a source and this is a destination. Okay, so what is important here to understand is, this will trigger a MapReduce job. See here, it says a job started. That's how the MapReduce job will start. Okay, we'll talk about the MapReduce job in the coming days, because we have not even started that, right? But after that it would make sense. But for now, you can just say that disk copy will always trigger a MapReduce job. Okay, and once this MapReduce job is over, you will see the output. You will see the data is copied successfully in our system, right? So this is a very minimal command, but I would say when you typically run your MapReduce job on a larger data set, you will write something like this. okay, wherein you'll have a configuration that can point to that has the capability to point to a production system or staging environment, and you can say while copying the data, because it's a map reduce job. Okay, now this is not a Spark job. Okay, so remember one thing, when you say that only Spark is important, okay, now when you do a disk copy, this is basically going to run a map reduce job. Okay, so it says, hey, while running my job, I want my map memory to be 2 GB. Okay, and I want at least 100 mappers to be used to copy this whole data from one machine to another machine, from one cluster to another cluster. So this will take good time, and then it will be done, and you should see the output like this. You should see the output like this, and it's all done, right? So see the output, you will see, you are able to see the details here, right? So this is typically how a map reduce job will execute. Okay, so once this is done, see, this is the command which we had executed, right? So now I'll say Hadoop fs-ls, right? So if you see, there is a file which was created, right? And this is created because of your disk copy. Okay, so the same command you go and execute on your production cluster, copy the data to your staging cluster, so to work. All right, next. Now, one more important thing, what you would basically be using is queue, the concept of queue. Okay, so see, when you are working on a real time, your team would be given a queue. Okay, at your team level, you would be given a queue. Who creates this queue? This queue would be created by your admins, right? Upon the approval and request. So they give you a queue, and that queue means a dedicated resources to process your job. Okay. Now by default, there would be a default queue, and if you don't specify any queue, then it will run on a default queue. It is possible to run a MapReduce job, Spark job in a dedicated queue. We will see that when we learn about it, right? But right now, what I'm trying to tell you is, if at all you have a job which is running on a default queue, and suppose you want to change the queue of it, which means, see, when you change the queue of it, what happens, the priority of the job will be more, and the resources which it is waiting in a default queue, it will immediately get a new resource. It's very simple. You have a job, let's say you are in a ticket counter and you are in a queue, right? And you don't have a dedicated queue because everybody is using a general queue, right? And let's say there is a dedicated queue started for people who are more than 50 years old. So what can people do is, all the people who are more than 50 years old, they can immediately join the new queue, and right, and then their ticket processing would be faster. And this is how it really works in the Hadoop also, right? So if you want to move one job from one queue to another queue to gain to gain more power, right? Because that queue will have a dedicated resources. So you can say yarn application hyphen move to queue, and then the application number, and hyphen queue, then root dot default. So this is basically your queue name. Okay, this is basically your queue name, and it can be anything, whatever you have in your environment. And what is this? This is basically an application number. Now let me give an example. See, right now we executed a disk copy, and as I have told you, every disk copy is basically a map reduce job, right? So if I just go up, so see this, I'm talking about this map reduce job, right? So let me go little up. Yeah. So when I went little up, if you see job underscore some number underscore some number, right? So this is basically the job ID. Okay, this is basically the job ID, and similarly you will have one application ID as well. Just a minute, I just wanted to show you this. Yes, so this is basically a job ID. See, that was basically a job ID. This is basically a job ID, and similarly you have an application ID as well. See, and the application ID is same 16. See, there's no difference here. 16079815001, right? So application underscore that number as well as job underscore that number, they are same, right? Now suppose this job is taking a lot of time to execute, right? and it is just because it is running on a default queue, and you want to change the queue of it. So what you will have to do is, from this job you'll have to find out the job ID, right? From this job you have to find out the application ID, copy this application ID, and then your command would become like this, right? And you're saying yarn application move to queue, this particular application should be moved to a queue. So in your case you will not have a default, you'll have some other queue. Okay, and that's how it all works, right? So I hope you are clear about this. Now these are some of the widely used what do you call commands in your job, right? So you can again go back and explore more commands. I'll show you one place where you can get access to all these commands, so that you can try it out, all the possible things possible, right? So you just say Hadoop commands. Okay, you just say Hadoop commands, you'll get a lot of articles, don't go anywhere, just stick to your Apache Hadoop guide. Okay, this is the best place to learn anything, and over the period of time I will make you get ready on learning all this stuff, because because see, I will not be able to cover everything, right? So I'll be covering whatever is required from developers point of view, but there are so many other commands which you may be interested to look into, right? Which are basically not a developer's command, which are basically admin's command, but maybe sometime later when you are working, you may be interested to know if I can do certain thing like this or not, right? So just go to the official documentation, right? So it says Hadoop apache.org docs current and so on. Now here you will find a lot of such command. Okay, here you will find a lot of such command. So let's see, user command class path dfs. Let me open this dfs. Okay, so it says sdfs dfs. See here, sdfs dfs, this is the same thing, Hadoop fs, whatever we were doing, right? And it says runs a file system command on file system supported in Hadoop. The various command option can be found at this guide. So again, open this guide, right? And now see, whatever we have learned mostly are from here: move, put, move to local, move from local, mkdir, ls, rm, set replication factor, tail, test, text, touch, z, chmod, chown, and so on, right? So we have basically learned most of the command which are available here, right? Because this is what you are going to do. But as I have told you, that you should also start learning how do you read this documentation, so that anytime when you feel that you want to check the syntax of some command, because today in December 2020 you are learning Hadoop, right? Now when you start working at a company, maybe let's say after 1 year, 2 years, 3 years, new Hadoop version will come, new command might get introduced. So what is the best place to learn? Not any article, but the official documentation, right? So this is what we have to start, taking it forward, right? So you click on any command, let's say chown, right? And it says changes the owner of the file, the user must be a super user, additional information is in this guide. -r option will make the change recursively through the directory structure. So this is the best place to learn all the possible commands, whatever you want to learn. Okay, so I would also give you this details on the chat box, so you can just have it. But see, I've already shown you how to get access to it, right? So it's recorded in the video, so you can just take it from there as well. Okay,